Okay, 7.6.4 is a big section, so we're going to want to pay attention to this. I'm going to start off with the conclusion so that you all know where we're headed. And the conclusion here at the bottom is the angle formed outside a circle by two secants, two tangents, or one of each is half the difference, subtraction, of the intercepted arcs. And here are the quick proofs. So let's start over here on the left. Right, we've got two secant lines, and we're trying to establish that angle E is half of DE at the top here. Whoops. Half of DE minus HG. Right, so we're going to establish the fact that if I draw in let's do blue. If I look at this connection, right, H to F. Well, what's interesting is that we now know that this is an inscribed angle here, and it is half of DF. Half of DF, right? It's half of the intercepted arc. This angle is also an exterior angle for this triangle over here, okay? And we also know that this up here is half, what is it? Half of HG. And so if we're trying to find E, watch what happens. Half of DF, right, we know half of DF is equal to angle E plus half of HG. Right, so you have this nice algebra, which is great. Angle E is equal to half of DF minus half of HG, or half of the difference of the intercepted arcs. Half the difference of the intercepted arcs. Okay, let's get rid of some of this junk a little bit here. Let's see if we can drop some of this. Just clean things up a little bit. Let's see. Okay, good. All right, next situation is this one where we have a tangent and a secant, right? And you notice similarly to the other one on the left, we've got some intercepted arcs. There's one here, and there's one here, all the way around to M, right? So that comes up with what is considered an intercepted arc. And let's do it in purple, why not? If I do the same thing and I connect this piece, what that's going to do is that what we have here, again, is a chord and a tangent, right? That is half of JM from the last screencast. This is also an exterior angle to the triangle right here, right? And so angle K plus this angle up here should be equal to half of JM. So we do exactly the same thing. And let's establish that this angle here is half of ML. Maybe you see that, half of ML. So write down again at the bottom, we're going to say that half of JM is the same as angle K plus half of ML. And that gives rise to this thing. Angle K is half of JM minus half of ML. Whoops, my handwriting is terrible, but hopefully you're listening to me. Okay, so same conclusion. And let's do this one more time, drop everything out, all the junk. On the final one, we have the exact same situation. And we're going to draw in this line. Because this line will create a chord and a tangent, and this angle is half of Rn. It's an exterior angle to this triangle. And so it's equal to, right? This will be equal to the sum of P plus this angle up here. And this angle, whoops, this angle over here, oh, didn't mean to do that. Oh, that's not good either. Let's see if I can get rid of the junk. I'm going to go back and essentially just say at the bottom here that angle P will be equal to half of Rn, the big one, minus Nr, the little one. Okay, so an angle on the exterior of a circle created by two secants, or a secant and a tangent, will be the half the difference of the intercepted arcs.